So you have the numbers 1, 2, 3 and 4. Okay. So now in this 1, 2, 3 and 4, the first number cannot be 0. If it is 0, then it will not be a 4-digit number at all. So first number has to be any of these 4. Any of these 4 means there are 4 options for this place. Now coming to the second place, one number is gone from here. So balance 3 is left plus the 0 is left. So again you have 4 options for this place. Now coming to the next place, one number gone here, one number gone here out of 5 numbers. So balance 3 numbers are left. So 3 options for this place. Now coming to this, 3 numbers are for this place. So 1 is used here. So balance 2 numbers are left which can be used for the last position. So this will be 24 into 4 is your answer here, 96. Are we clear? Can we continue?
Yes.
Yeah, we'll go to question number 6. Maybe somebody else wants to read. See, Sashank, to read.
The number of 4. Shall I continue?
Okay, yeah, sure, continue.
The number of 4-digit numbers. The number of 4-digit numbers greater than 5000 can be formed out of the digits 3, 4, 5, 6 and 7. No digits is repeated. The number of such is.
This is a case where I have a condition added. Number of 4-digit numbers greater than 5000. Greater than 5000 and there is no 0 here, but this is a condition. So underline the condition. So I have underlined 0 here. So each question you please underline. Here you underline odd places. So like that, there is something unique about every question that we have picked up here. Okay, we have 3, 4, 5, 6 and 7. And you're going to form numbers greater than 5000. Only 4-digit numbers but. So 4-digit numbers means 4 dashes. Greater than 5000 means first letter can be either 5 or 6 or 7. Any of the 3 letters. So there are 3 options here. Coming to the second dash, 1, 2, 3, 4, 5. Out of 5, 1 is gone here. Balance 4 left. So here balance 3 left, here balance 2 left. So what you have is 24 into 3 which is 72. Are we clear? Shall we continue? We'll go to the next question. Question number 7.
Yes, ma'am.
Sorry? Sabarish, did you say something? You are unmuted, so I think you're saying. Okay. So we haven't heard Anirudh's voice today. So you want to read Anirudh? You joined late today?
No, I was there from the start though.
Okay.
Yes, ma'am. So, 7th one, right?
Yeah.
Yes, ma'am. So, how many ways can 8 persons be seated in a round table? In how many cases will 2 particular persons sit together?
Okay. So in how many ways can 8 persons be seated in a round table? So round table, circular permutations I have told you. Circular permutations for people it is n minus 1 factorial. For any inanimate objects or beads in a necklace is n minus 1 factorial divided by 2. Okay. So this is for circular permutations when you are having people. So in this case 8 persons at a round table will be 8 minus 1, 7 factorial. Okay. So that is the answer for the first part. Second part says in how many cases will 2 particular persons sit together. So let's say you have 2 particular persons. So person 1, person 2. These 2 persons want to sit together. So make them one block. Balance how many people will be left? Out of 8, 2 gone. So balance 6 left. So one block plus 6 people will make it 7 people. 7 people in a circle is 7 minus 1, 6 factorial multiplied by this. These 2 persons between themselves can be done in 2 factorial ways. Okay. So 6 factorial into 2 factorial is the answer. Are we clear? We'll go to 8th question. Continue, Anirudh.
Yes, ma'am. A family of 4 brothers and 3 sisters is to be arranged for a photograph in one row. How many ways can they be seated if all sisters are together? No two sisters sit together.
Okay, so family of 4 brothers and 3 sisters is to be arranged for a photograph. Okay, so they are asking you two things. One is if all sisters sit together. So there are 3 sisters, sister 1, sister 2, sister 3. So all 3 of them sitting together in this manner, and you have 4 brothers. Okay, so 4 brothers, this makes it 1 block plus 4 is 5. So it can be done in 5 factorial multiplied by 3 sisters among themselves is 3 factorial. Now the next question is no two sisters sit together. So this is where I want you to pay your attention. Okay, we have not done this type in any of the problems above. No two sisters sit together means brother 1, brother 2, brother 3 and brother 4. In between these people the sisters are going to sit. Okay, in between these sisters. So how many places they have? 1, 2, 3, 4, 5. So they have got 5 options to sit. So first sister, the second sister has got 4 options, the third sister has got 3 options, and the 4 brothers among themselves can sit in 4 factorial ways. So the 4 brothers will sit in these places, these are fixed places, between these the sisters will sit. So 5 into 4 into 3 into 4 factorial will be the answer for this part. Okay, so this is something we have not done earlier. No two sisters sit together, this is slightly different. Okay, shall we go to the 9th question? 9th and 10th are little bit unique. We'll come to 9th and 10th, maybe we'll do 11th and 12th and then we'll do it. 11, 12 and 13 we will do and then we'll come back. Okay, yeah, come to the 11th one.
Yes, ma'am. In how many ways can 5 people occupy 8 vacant chairs?
So there are 8 vacant chairs and there are only 5 people. Okay, so 5 people, person 1, person 2, person 3, person 4, person 5. See, you can solve everything in permutations with just logic. Okay, so the first person has got 8 options, next person has got 7 options, the next one has got 6 options, the next one has 5, and then the last one has got only 4 options. So this is how we do it. Okay, just multiply.
Ma'am, we can do 8p5 also, right?
Both are same.
Yes, ma'am.
Out of 8 places he selects. So anyway 8p5 you have to expand it. When you expand, simplify the formula, it will come to this only. So instead you can do this straight away. Okay, next question. Question number what I did now was question number 11, right? So next is question number 12.
If there are 50 stations on a railway line, how many different kinds of single first class tickets may be printed to enable a passenger to travel from one station to another?
Yeah, there are 50 stations in a railway line and a passenger is going to print single first class tickets. Okay, so I used to tell you the example of 10 stations in a row, right? So let us just look at that example once again. So there are 10 stations in a row. Okay, let's say the first station is Tambaram, second is Sanatorium, next is Krompet and the last is Beach. So totally 10 stations. So suppose you board the train in Tambaram, how many single tickets can you take? You can take a ticket for any of the remaining 9 stations, right? So from Tambaram you can take for any of the remaining 9 stations. Suppose you board the train in the second station, Sanatorium, because we don't know where you're going to board the train. So suppose you're going to board in the second station, also you can take for the remaining 9 stations, correct? So like that you can take for 9 stations from any of the 10 stations. So totally you can take 10 into 9 number of tickets, because there are totally 10 stations and from each station you can take 9 tickets. Now the same analogy if you apply for 50 stations, from each of the 50 stations you can take 49 tickets, right? So 50 into 49 are the different possibilities that you have before you, because you don't know the passenger is going to come from which place and he is going to go to which place. So that way, if you are just trying to explore what is the maximum number of tickets that a person can take, it is 50 into 49. Are we clear? We'll go to question number 13. Yeah, please read. Are you all able to hear me? Are you all able to hear me?
Yes, ma'am.
Yes, ma'am.
Yeah, sir, can you continue reading? Can you go to the next question? I think Anirudh is not there. Then maybe somebody else. Jinal, you were not there in the beginning? I see your name only now. You're not there now also?
Oh, ma'am, sorry, ma'am, I didn't unmute. I'll read.
Okay.
Yes, ma'am. In terms of question number 41, ma'am,
Yeah, you read it, I'll tell you what to do.
yes, ma'am. In terms of question 41, what is the rank of or the order of the word zenith in the dictionary?
Yeah, the question number 41 is nothing but in how many ways can you arrange the word zenith? Okay. So, how many ways can you arrange the word zenith? Zenith is Z-E-N-I-T-H. 6 letters, nothing repeated, so 6 factorial. So 6 factorial means how many ways? 120 words can be formed, or 120 words can be listed in a dictionary. So when you list down these 120 words in a dictionary, what is the rank of the word zenith? The question is, what is the rank or order of the word zenith in the dictionary? So 120 words will be arranged in the alphabetical order. Alphabetical order, correct? So alphabetical order, what happens? The letter Z is the last letter of the English alphabet. So all these letters, these are all 5 letters, all the 5 letters will come before the word zenith, okay, before the letter Z. So 1, 2, 3, 4, 5, 6. Suppose you have 6 dashes. The first dash can be occupied by E, N, I, T or H. Any of the 5 letters can come here. Then it will be before the word zenith. So how many words are there which start with letters other than Z? So first place I can have 5 options. And then the next place will be out of 5 1 gone. So out of 6 1 gone. So again 5 is left. Now 4, 3, 2 and 1. So that makes it 5 factorial. 5 factorial into, sorry, this is actually this is 720, no, not 120, because 5 factorial is 120. 120 into 5 is 600 words, because you're going to get 600 words here, which are words which are starting with letter other than Z. So all these 600 words will come before zenith. So will zenith be the 601st word? That we have to check now. 1, 2, 3, 4, 5, 6 dashes. Suppose a word begins with Z. Okay, we have looked at words which don't begin with Z. Now what about words which begin with Z but are before zenith? Okay, now first letter, let us fix it. We'll fix it with Z. Now come to the second letter. Now suppose the second letter is anything other than E. E, N, I, T, H. Look at these letters. Which letter comes alphabetically first? It is the letter E which comes first in the alphabetical order. So if I put any other letter here other than E, it will not be before zenith, it will be after zenith. So here logically no other letter should come except E. So let me fix this place also with E. So these 2 letters are fixed. Come to the third letter. Look at N-I-T-H. Now out of N-I-T-H, I and H are 2 letters which come before N. So there are 2 options for this particular place. Okay, now coming to the balance, 3 letters, 3 factorial. Okay, because this can come in any order, doesn't matter. In these 3 places, any order, it doesn't matter, it will still be before zenith, because the third letter instead of N I have taken I or H. So now what will happen? 3 factorial is 6, 6 2s are, there are 12 words again which begin with Z, which have the second letter E, third letter instead of N I have replaced it with I or H, and therefore there are 12 words which can be written before the word zenith. Okay. Now let us explore some more possibilities. Z is fixed, E is fixed. Third letter's possibility we have seen. Now let us fix N also. Okay. So all the 3 are fixed. Now the possibility of the third letter is nothing but, already it is I. Now look at the letter T and H. T letter comes after I. So this cannot be used, T cannot come here. So this place only H can come. The moment H comes, it will be a word before zenith, okay, because H comes before I. So I can put H here, and here the balance 2 can come in any order. So this will become 2 factorial. 2 factorial means 2 words. So totally there are 2 more words where the first letter is Z, second letter is E, third letter is N, the fourth letter is H. Okay, so the fifth letter could be I and T or T and I. Those are the 2 different possibilities. So I have 2 more words. Okay, now let us look further. Again 6. So Z, E, N, these 3 letters I am fixing. What about I? I also I will fix because I have already checked with H. So now these 4 letters I have fixed. Now coming to the next letter. Okay, here if I put T itself, it will become zenith only. So instead of T, if I put H here and then I put T here, this will be a word before zenith for sure. Okay, so there is one more word that can come before the word zenith. Are we clear? So now count all these words. How many words are there? 12 plus 2 is 14. 14 plus 1 is 15. There are 615 words before the word zenith. So zenith will occupy the 616th position. Are we clear? Is there any doubt with students on this particular one? So shall I?
No, ma'am.
Okay, good. So let's proceed to the 2 sums which we left, that is question number 9 and question number 10 we will do now. Okay. So question number 9 and 10. What is unique about this? Okay, read it, Anirudh.
The number of arrangements of 10 different things taken 4 at a time, in which one particular thing always occurs is.
Yeah. So they are telling you that one particular thing always occurs. So let us underline this, one particular thing always occurs. One particular thing always occurs means what? Let us understand that. So the question says there are 10 different things. Okay. So n is 10. You're going to take out 4. So R value is 4. One particular thing always occurs. So what it means is, out of 10, one object should always be there in every one of your arrangements. Okay. So there is no question of this particular object being missed out. So underline one particular thing always occurs. So in this, instead of introducing new formula to you, there are formulas available for 9th and the 10th. One particular thing always occurs and one particular thing never occurs. So instead of introducing a formula, what I can tell you is, without a formula, how do we do it? Okay, without a formula, now permutation is nothing but both combination and permutation put together. Okay, permutation is nothing but combination, that is first we have to select, then only we can arrange. So permutation, actually the first step is selection. So we are going to select 4 from 3. 4 from 10. But in that 4 selection, one particular thing is already selected. So which means we have to select only 3 from how many? From 9. Okay. How do we do that? We do that by using the formula 9C3. Okay, from 9 I am selecting 3 because one particular thing always occurs. So that one particular object I have kept it here separately in that box. Okay, that one particular object is there in that box already. So the remaining 3 only I am going to select. How do I do 9C3? 9 factorial divided by 3 factorial into 9 minus 3 is 6 factorial. Now after selecting, I have 4 objects with me which I have to arrange. So 4 objects are arranged by doing 4 factorial. Okay. So now how we are going to cancel is this and this you cancel, you will get 4. This and this you will get cancel, you will get 9 into 8 into 7. So all you have to do is multiply the 2. 9 into 8 into 7 into 4. Okay. So you will get 2016. This is what you will get. Are we understanding? I have done this using the formula for combination NCR. NCR is nothing but n factorial divided by n minus r factorial into r factorial. This is the formula. Okay. Yeah, come to the next one. Can you read the next one? The number of permutations of 10 different things taken 4 at a time in which one particular thing never occurs. One particular thing never occurs. What happens when one particular thing never occurs? Okay. So this is in the opposite of one particular thing always occurs. In this, one particular thing never occurs. So I don't want to select one particular thing. So let me remove that one particular thing from the total objects itself. Let me make the total number of objects 9 because I don't want that one particular thing. I want to remove it and throw it. Okay. So I am removing that one object and putting it in a basket in which I don't want. Okay. So I have only 9 left now. Now from the 9 I am going to select 4 and then I am going to arrange the 4. Okay. So this is the answer for question number 10. 9C4, first select 4 and then arrange 4. How do we do that? 9 factorial by 5 factorial into 4 factorial into 4 factorial. So we will cancel these two. 9 factorial by 5 factorial you will calculate as 9 into 8 into 7 into 6. So just calculate this and see what you get. You must be getting 3024. Are we clear? I think you all must be able to hear me.
Yes, ma'am.
Okay. So Krishna Prasad, you want to read the next one? I haven't heard you at all so far. Did you join in late?
Yes, ma'am.
Okay, so you want to read the next question? The next
11th question, ma'am.
No, we have finished all that. So we have finished all the 13th questions. All the 13 questions here. We'll move on to combinations. We'll move to combinations now. Okay, I've already introduced you combinations by doing this. See, permutation is arrangements, but combination is only selection. So there's no question of arrangement here. So let me write down what we mean by combinations. Okay, let's do that here. In combinations, we are only going to select. How are we going to select? We are going to select from n number of objects. We are going to select r number of objects. So n factorial divided by n minus r factorial into r factorial. This is the formula. Okay. So if I give you an example, let's say 5p3. 5p3 is nothing but 5 factorial divided by 5 minus 3 is 2 factorial into 3 factorial. So how we do this is expand this up to the bigger number. So 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial. These two will get cancelled. 5 4s are 20, 20 by 2 is 10. 10 is your answer. Okay, so that's how we do these kind of questions. In other words, if you want to simplify, all you have to do is see how we normally do this in how I taught you the shortcut is 5p2. Okay, 5p2 how we calculate is two numbers, no, so only 2 here, so 5 into 4 only you will multiply. In case of this is not 5p2, this is 5c3, no. In case of permutation we do 5p2 only 2 numbers, no. So in case of combinations it will be 5 into 4 divided by this 2 factorial here additionally, that is the only thing. Okay, so what will happen is 5 into 4 is 20, 20 by 2 is 10. Now we have a formula where we say 5c3 is equal to 5c2. Okay, now 2 plus 3 if you add, what you will get is 5. Okay, so take another example. 7c3 will be equal to 7c. Anybody wants to say? Krishna Prasad?
4.
4, ma'am.
It will be 4 because 3 plus 4 is equal to 7. So this shortcut becomes very useful for us in the calculations. So that's why I keep telling students to write in the last page of your notebook like something like this. Okay, what do you write? 4c1, 4c2, 4c3, 4c4. Okay, now I'll tell you how to fill this up easily. First let's understand 4c1 and 4c4. So how do we do that? Let's write down here nc1. What will be the value? It is n factorial divided by n minus 1 factorial into 1 factorial, which is nothing but n into n minus 1 factorial. I'll expand up to this number. Then denominator is n minus 1 factorial into 1 factorial. So we'll cancel these two. I'm left with only n. So nc1 is n. Okay, nc1 is n. Even if you don't remember in the examination, I'll just tell you a logic. You have n number of objects. From that you have to pick only one. Okay, take a number, you have 5 objects with you. From the 5 objects you have to pick up only one object. In how many ways can you pick up one object? You can pick up any of the 5 objects. So therefore your answer becomes 5. Correct? So nc1 becomes n, that is why. Okay, nc1 becomes n. Okay, now come to ncn. What is ncn? Okay, you tell me, even without calculations, you have 5 objects. From the 5 objects you have to pick up all the 5 objects. In how many ways can you do that? Anybody? Krishna Prasad? One way only. Correct. Because from 5 objects you have to pick up all the 5 objects. In what other way can you do? Only one way. So that is why ncn is always 1. So if I write it in terms of formula also, this is what it becomes. This and this gets cancelled. N minus n is 0. 0 factorial is 1. So the answer you get is 1. So these are things I want you to make a note of with a different color pen. NC1 value, NCN value. This is very important. Now that you know this, filling up this becomes easy. 4C1 will be 4. 4C4 will be 1. The moment I fill this up, 4C3 is equal to 4C1 because 3 plus 1 is 4. So this value becomes same as this. Now 4C2 becomes easy because of this particular shortcut I taught you. That is 4 into 3. 4 into 3 is 12. 12 by 2 factorial is 6. So answer becomes 6 here. Are you understanding how easy it is to calculate? So next similarly I will show you 5 series. You all can calculate along with me. Phi C1 is 5 itself, phi C5 is 1. So moment you fill phi C1, you can fill phi C4 also. Phi C4 is actually 5 again, value will be same. Now come to phi C2. Phi C2 is 5 into 4, 20, 20 divided by 2 factorial, not 2, 2 factorial. So 20 by 2 is 10. So this and this are equal, so automatically this becomes 10. So is it not easy for you to calculate like this? It becomes easy to fill up the values. So I normally I have told students to fill up the 6 series, the 7 series and the 8 series also this way and refer it. Okay. Now let me show you the 8 series, how easy it is to fill up moment you know these kind of shortcuts. You have so many numbers, but it is so easy to fill up. 8C1 is 8, 8C8 is 1. Moment you fill this, this becomes easy. 8C7 is also 8. Now coming to 8C2. 8C2 is 8 into 7, 56. 56 by 2 is nothing but how much?
28.
Correct.
28.
So all of you are able to hear me. So 8C2 is 28, therefore 8C6 is also 28. Both you can fill up simultaneously. Now come to 8C3. 8C3 will be nothing but 8 into 7 into 6 divided by 3 factorial. So all you have to do is 28 into 6 divided, 8 into 7 into 8 into 7 into 6 divided by 3. Divided by 3 factorial. So 8 into 7 into 6 divided by 3 factorial is 6. So that comes to 56. Moment you fill this up with 56, this will also be 56. Okay, because this and this are equal. Or another way to do it is you can just do 28 into the additional multiplication here is 6 and additional division is 3. So this and this is 2. 28 into 2, 56 is your answer. Are you clear? Now coming to 8C4. 8C4 similar analogy. 56 additional multiplication you are going to do is 8 into 7 into 6 into 5. The fourth number is 5 divided by additional division is 4. So you can just do 56 divided by 4 into 5. So the answer becomes 70. Easy? Okay. So this is what you have in terms of combination. So are you all clear with all these things so far? You please write this somewhere. It will be very useful for you when you are actually doing the calculations. Okay. So I will give you a couple of problems, 1 or 2 problems we will try now, and then we will discuss. Yeah. Okay. So let's start with the first one. A person has got 8 friends. In how many ways he may invite one or more of them? So a person wants to invite 8 friends to a party. In how many ways can he invite one or more of them? Underline the words one or more of them. One or more of them means he can invite from 8, he can select 1, or he can select 2, or he can select 3, or this is how it goes. From 8 he can select 4, he can select 6, he can select 7, or he can select 8. 8C8. This is how it comes. So all the values you know you can write here. You can say 56, 56. This is the advantage of knowing it thoroughly. Use a calculator, calculate. Otherwise you can use a formula shortcut 2 power n minus 1. 2 power n minus 1 shortcut is 2 power 8 minus 1. 2 power 8 also I have told you to write in the last page of your notebook. That is, it is 32 into 8. 256 minus 1, answer is 255. Are we clear? 255 is supposed to be the answer. This shortcut is very, very helpful when we are doing these kind of problems. Now coming to the second question. The number of parallelograms that can be formed from a set of 4 parallel lines intersecting with another set of 3 parallel lines is how much? So some small application to permutation. 4 parallel lines intersecting with 3 parallel lines. How many parallelograms can be formed? To form a parallelogram, you need 2 lines from this side and you need 2 lines from this side. Okay. So how do you select 2 lines from 4 lines? It will become 4C2. And 2 lines from this side will become 3C2. So the answer becomes 4C2 into 3C2. Okay. You must remember these values thoroughly. 3C2 is equal to 3C1. 3C1 is 3. So 4C2 is 4. 4 into 3 is 12. 12 by 2 is 6. 6 3s are 18 is the answer. So don't calculate. Don't sit and do 4 factorial, 3 factorial, all those things. Save your time. Remember these numbers. It will become really very easy for you in the exam. Okay. So let us proceed to the next question. A committee of 3 ladies and 4 gents is to be formed out of 8 ladies and 7 gents. Mrs. X refuses to serve in a committee in which Mr. Y is a member. The number of such committees is how many? Okay. Now this is a very unique question, that's why I picked this up. You are to form a committee where there are how many? So you have ladies, you have gents. Okay. So total number. Committee formation is a very typical question in combinations. There are totally 8 ladies and there are 7 gents. To form a committee, you need about 3 ladies and 4 gents. Okay. So 3 ladies and 4 gents. Mrs. X will come under this category and Mr. Y will come under the gents category. So Mrs. X says, I don't want to be there in the committee in which Mr. Y will become the member. Okay. So what are the different possibilities? The first possibility is Mrs. X also you don't select. Don't select. Okay, because she doesn't want to come if Mr. Y is there. So don't select Mrs. X if Mr. Y is there. So you have selected Mr. Y. So you have selected Mr. Y, so you are not selecting Mrs. X. So how do you select Mr. Y compulsorily? You will select him by removing him from the total and from this, because you have anyway selected him. So what you do is 6C3 is compulsorily selecting Mr. Y. We just discussed few minutes back in permutations, right? First is combination and then permutation. That question that I am applying the combination part here. Now coming to this, you don't select Mrs. X, but you still have to select 3 people. So Mrs. X is there in the total, I am removing her from the total. So 7C3 into 6C3 is the first way to do it. Now the second way to do it is Mrs. X you don't select and Mr. Y also you don't select. Okay, we don't want people who are creating problems. So I am not going to bring both of you in. So if I don't select, this part is anyway 7C3 and this part is I have to select 4 people. There is no other choice, but I don't want Mr. Y. So I will remove him from the total. Okay, now the third way in which I can do this is Mrs. X you select. Instead you leave Mr. Y. Mr. Y you don't select. So don't select I have just done here, which is 6C4. Select part I have not yet done, so I am going to select. How? I am going to select because she is compulsorily selected. So I need to select only 2 more people now from 7 more people. Are we clear with this?
Yes, ma'am.
Okay, so this is one very unique question. So that's why I am not going to calculate the values. I think all of you can calculate, that part is fine, because we have 7C3, 7C2, how to calculate I have taught you. 6C4 again, find out 6C2. 6C2 is 6 5s are 30, 30 by 2 is 15. So this value becomes 15. It becomes 15 here. It's easy to calculate that way. So here it will become 6 into 5 into 4 divided by 3 factorial. So 5 4s are 20. Becomes easy to calculate these in this way. Are you understanding? Okay. So 7C2 is also 7 into 6 is 7 into 6 divided by 2. So you will get 21. Okay. So like that you can calculate it easily in the examination. So don't worry about it. Let us go to the next problem. Question number 4. So we have 2 problems now. Question number 4 and 5. We'll finish this and then we'll see what to do after this. Yeah. Can you continue to read? Okay. Who was reading it? Archana, you want to read? I don't think you have read today.
Yes, ma'am.
Yeah, please read the question.
Which question, ma'am?
You read the next question, question number 4. We are in question number 4 and 5. These two are left. You keep reading. I'll join you guys in a minute.
Fourth one, ma'am.
Sorry. I was on unmute.
Ah.
Yeah. Please read the fourth question. Okay. I'll
Okay,
join
ma'am.
you in a minute.
Okay, ma'am. The ways of selecting 4 letters from the word examination is
Okay, I hope you have read the question. So let us solve now. This question I have written down because it's a very unique question. The word examination, you're supposed to select 4 letters. All of you can hear me, right? Archana, you can hear me?
yes, ma'am.
Okay, examination. Examination, how many letters does the word examination have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it has 11 letters. 11 letters. Let us just examine what these letters are. Okay, repetition and non-repetition, we will write it separately. E, X, M. A is repeated 2 times. Let me write that separately. I is repeated 2 times. N is repeated 2 times. Those are separate. So the remaining letters are M, T, O. So 5 and 6 makes it 11 letters. So this is how this examination word is. Okay. Now how many ways can you select? The ways of selecting 4 letters from this word. In how many ways are you going to select 4 letters? Okay. So, idhe question, the same question is there with different words in the textbook. One of them is the word mathematics. The other word is combination. Now, these are also the same words, okay? Because if you see in combination also, CMO is repeated 2 times, CMB, I is repeated 2 times, N is repeated 2 times, A, T. So 5 plus 6, same way, same pattern. In mathematics also, if you see, it is nothing but M is repeated 2 times, A is repeated 2 times, T is repeated 2 times. Remaining H, E, I, C, S. 5 and 6, same pattern, okay? So these 3 in the 3 question, enna question vandalum, the approach is same. You can in fact even tick the answer straight away in the exam, no need to even solve it. Okay, so let me just explain the logic. Suppose you get a different question other than these 3 words. Suppose you get a different word in the exam. So in how many ways can you select 4 letters? So you're going to select 4 letters. How will you select 4 letters? Now 5 different same. So first option that you can select is all 4 are different. All 4 are different means how you can select? You can select 1, 2, 3, 4, 5 different, and idhula vandu 3 different. So 5 plus 3, 8. Totally 8 different letters are there. So from 8 I am going to select 4. So it will become 8C4. So I can select 8C4. From 8 I am selecting 4 letters. Second, 2 are different. 2 are same. Okay, 2 are same means from this set of 6 letters I am going to select 2, okay, which are same. So I am going to select which are same. So which means I have 3 pairs. From the 3 pairs I have to select 2. Okay, and now I have to select 2 from the remaining. Now what are the remaining? I have selected, let's say, some A, then I and N is remaining, and from this 5 are remaining. So 5 plus 2, 7 different letters are still left. From that I have to select 2 letters. That's how I will get 2 different and 2 same. Now how else can I select? Sorry, there is one mistake that I have done here. Can anybody say what it is?
3C1, ma'am.
Correct. It should be 3C1 because from 3 pairs I'm selecting only 1 pair. Okay. Okay. Now 2 same plus 2 same. That will be nothing but from 3 I take 2. From the 3 pairs I select 2 pairs. So AAII, that will come here. Okay. Are we clear with this? Next part is calculation. Calculation part, don't worry much. Can I proceed, students? Can I go to the next question and probably the last question here? The 5th one. Yeah, read, Archana.
The number of different words that can be formed with 12 consonants and 5 vowels by taking 4 consonants and 3 vowels in each word is?
Why this question we have selected is, this your question asking how many words that can be formed. So it not only involves selection, it involves arrangement also. Okay. So how many consonants I have? I have 12 consonants, I have 5 vowels, just like my committee question. Okay. Same table format I will put here. And how many different words are we going for a word? How many consonants I need? I need 4 consonants and I need 3 vowels. So how will I do the selection? I'll do 12C3 into 12C4 into 5C3. Now I have selected. Next is for me to arrange the 7 letters to form different types of words. So into 7 factorial. Are we clear?
Yes, ma'am.
This is how we will do it. Okay. So what we will do is we'll probably wind up today and probably we'll spend a little extra time in the evening. Okay. I think we are a little bit low on energy also because I see some people are feeling a bit tired. They are quitting towards the end, and I think you've already finished accounts revision, you've finished economics revision so far, and you've finished what other subject? Law also is over.
No, ma'am.
So what, a BCK is done?
Yes, ma'am.
So yeah, I think the exhaustion level has come towards your end. Anyway, not an issue. It is sufficient if you do whatever we are doing now for revision is good enough for maths. Okay. So we are going at the right pace, not to worry. We will meet at 4 o'clock in the evening. Okay.
Thank you, ma'am.
Thank you, ma'am.
You're welcome. Good day.
Ma'am, in the above question that we did, no, ma'am, this fourth question. Suppose if they ask arrangements, then we should include the arrangements also, no, ma'am.
You mean to say an examination question?
Yes, ma'am.
Okay, I'll tell you that now. Suppose they tell you arrangements also, what happens is, in each of this calculation we should you will get the answers, no? In this you should arrange. For example, 8C4 is separate. For this you should do separate. For this you should do separate. How? 8C4 is 4 different letters, so straight away 4 factorial you will multiply. Now for this again it will be 4 factorial, but divided by 2 factorial because 2 are same. Now here it will be again 4 factorial divided by 2 factorial into 2 factorial because 2 same and 2 same. This is how you will do in case it is an arrangement.
Okay, ma'am.
You clear with this?
Yes, ma'am.
Okay.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
We'll meet at 4 in the evening, okay?